Good morning, students. Again, let we have to be discuss another topic in that machine learning, where the term is called that machine learning models. So before that, let we have to see what are all the ingredients of that machine learning. When we say that is a model of that machine learning, so one thing we have to be definitely know, it is called that is models lend the machine learning field diversity, but task and features give it unity. So this is that primary scenario of that models in machine learning. Models lend the machine learning field diversity, but task and features give it unity. So this is the phenomena we have to be follow. And now we have to see what are all that primary ingredients or that primary task of that machine learning. So in case most machine learning tasks are predictive, the purpose of that machine learning is we have to get that is the prediction already trained data set. So this is the primary task of that machine learning, in the sense that they concern that predicting a target variable from the features. So let me say, so what are all the kind of the features that we have to be learned? That number one is called that is the binary and multi-class classification, or another term is called that categorical target. And number two is called that is the regression, that is for the numerical target. Number three is called that is the clustering, it's that's for the hidden target. So these are all the three kind of that task that we have to be perform in a machine learning trained data set. In case I am feeding that is the data that is comes under that category kind of the thing, and then I have to be go for that binary or that multi-class classification under that banner of a categorical target. In case the trained data set it's having certain of numerical values, that I have to make that relation among that is the numerical values, then I have to be go for that regression. So that gives that outcome of numerical target. And also number three, in case the data may be hidden into the data set, such a situation that we have to be go for the clustering that is purely for that hidden target. And descriptive tasks are concerned with that exploiting underlying structure in the data. So in that scenario that we have to be say that is of the structure in supervised and then unsupervised learning. In the supervised learning, we say that is in the predictive model, we have to be go for the classification and the regression. And if it is in a descriptive model, that we have to be go for the subgroup discovery. In case of that unsupervised learning, in predictive model, we have to be go for the predictive clustering. But in case of the descriptive model, we have to be go for the descriptive clustering and association rule discovery. So this is the scenario we have to be follow up. And now we have to be talk about that machine learning models. So this is that foundation based on so what we discussed on earlier. So in that machine learning model, we have to be three main models we have to study. Number one is called the geometrical model, and number two is called that is the probabilistic model. Number three is called that is the logical model. So in that geometrical model, we are using that is the intuitions from the geometry by separating that data by the planes or by the linear transformations or by the distance metrics. In that probabilistic model, we are going to be study about that process of reducing that uncertainty and that model by that probability distribution. And in that logical model, in the term itself, we are having that term solution and answer. We are applying that is the logical. That means either the 1 or the 0. So according to that, we have to be apply these things in your data set, and we are getting and also we are applying that is the logical expression, and we are getting that outcome for that. Apart all these things, let me have to go for that another setup of that models is called that grouping models and then the grading models. In that grouping models, we are divide that instance space into the segments. In each segment, a very simple constant or that model is learned. And in the grading model, we are applying that is the learning by the global model over the instance space. So these are all that five kind of the models, but in the primary we are going to study about geometric model, probabilistic model, logical model, and finally we have to be discuss about that grouping models and then grading models. And now let me have to be come to that geometrical models. In geometrical models, the term is called that the basic linear classifier. In that basic linear classifier, I am having that one set of the data. In that set of the data, I am drawing that is the one threshold line. So in case of if I am saying that is the threshold line, that point should be that very important. At what point I am doing that is the classification. So for that I am applying that is one formula. I am having that one line is called that is the P, and another one line is called that is the N. In among that, let I have to be take an average, that is the P plus N by 2. So I am having that only two parameters, P and then N, and for that distance I am making that is one average. So in that midpoint I am drawing that is that another one line or that another one spot. So from that spot, let I have to be distinguished. So what are all the parameters available above the spot, and then so what are all the parameters below that is the spot. In simple, let I have to say I am drawing that is the line, and above that line, so what are all that group of the data, and below that is the line, so what are all the group of the data. So above the line, the group of data it's called that is the positive data, and below that is the line, the group of the data is called that is the negative data. The positive data is the data so what I am expecting. So in such a way, I am drafting that a line in between that data set. Such a model is called that is the probabilistic geometrical model, and the next one is called that is the probabilistic model. So in that probabilistic model, I am applying that is the probability among that set of data by that decision rule, that is probability in between y and x. So in that scenario, I am applying that is the decision rule. Say to classify that one email, I am having that is the word is called ATM pin and then so lottery. So it look up the corresponding probability by P of y equal to ATM pin or the probability of with lottery, and predict that if it is the spam or it is not a spam. So the ATM pin, it maybe comes as a spam, and then so today we are facing there is the several scenarios by duplicating their accounts, and then the people are making fraudulent mechanism to extract that PIN number from the customer. So that we have to be identified. So this is from that genuine bank communication or from that fraudulent mail. So for that we have able to apply that is probability. So in a set of the miles, so what are the miles, it's having ATM PIN, and with that another scenario it's called that is the lottery or that other thing. So let we have to be make that correlation through by that probability. So I am applying that is the decision rule there. In that moment, the probability of y of x in that decision rule, the result is makes an outcome. So I am getting that is the positive, and then I can able to say that mail is positive. If I am getting that is negative, and I am saying the mail seems to be that spam. So for that I have to be applied that is the probability value. In case the probability of that ATM, I may have that 0.65, and for that probability of that mail I am having that is the spam, it may be that is 0.35, and I have to apply that is the relativity among that 0.65 and 0.35, and let I have to come to the conclusion this is a spam or that ham. So ham means that is the genuine mail, and spam means this is a fraudulent or that spam mail. So I can able to apply that is the relationship in between of the data sets by applying that's a probability model. And that's the next one, it's called that is that a logical model. So in that logical model that I have to say, now I am having that two terms is called that is the ATM pin and the lottery. So in that mail I am looking for that is the ATM pin. So that ATM pin is that is equal to 1. I can able to come to that conclusion it may be that ham. And I am getting that is the 0, and again I have to be checked out for for that lottery. So in case if lottery is 0, I may come to that conclusion it may be that a pure genuine mail, because I am having that is ATM pin alone, I'm not getting that information related with that other things, kind of lottery or that any other links. So I can able to come to that conclusion. It may be that good mile or it may be that ham. In case for that in lottery decision side, I'm getting that is the one, and then I can able to come to that conclusion. It may be the spam. So ATM pin is also that available, and that lottery is also available, and then I can able to come to that conclusion. The mail may be come from that is a fraudulent. So in such a way, let I have to be come to that conclusion by that probabilistic model, the mail is genuine or not. So these are all that three kind of that models that we have to be important when you have to be give that decision making in a set of the data sets. Number one, in case I am applying that decision rule through by the geometrical model, then it is called that a geometrical learning method. And number two, if I am applying that learning mechanism through by that probability, and then it's called that is the probabilistic model. And number three, if I am applying that decision through by that logical model, so then it is called that is the logical learning method. So these are all that three basic things that we have to learn.